Welcome to my third video in the series of videos that I have produced in which I'm attempting to measure the shape of the surface of the Earth using empirical data and analysis. In this video, I'm going to be using the video that you see here. It actually isn't video that I collected. I've actually worked with Bo, who runs the BMLSB69 channel. We did collect some video of offshore platforms. We weren't entirely successful. We couldn't get to the exact elevation that we wanted to get to or in the exact line. We were trying to get in a perfect line with offshore oil platforms that are 10 and 20 miles offshore. We also had issues with visibility, and I actually made some mistakes as far as what elevation we were supposed to be at. I assumed the oil platforms were much taller than they actually were, and the formula, the 8 inches per mile squared, I was actually using that to determine how sunken down the distant platform should be, but we were actually shooting across the air, and so that formula wouldn't work in that case. But I'm not going to get into that. I mean, I did actually figure out eventually how to make that calculation, but we ended up not getting the video. And in my frustration, I started looking at a lot of his videos and ran across this one, which I saw something in it that is, well, once I started looking at it and getting all of the information as far as the elevations and the distances, that what I started seeing was that this video very strongly suggests that the surface of the water is curved. But I could be completely wrong. I'm not going to say that that is what it's saying. But what I'm going to do is just share this video with you. It's actually all in the first minute and a half of the video. So I'm going to pause it a lot and rewind it. And then I've got diagrams and some maps and photographs, and I'll put it all together and then let you just make up your own mind. And I would appreciate any feedback to tell me what you think, if you think that this does actually suggest that the surface of the water is curved. So with that, I'm going to go ahead and play this. Actually, I'll expand it, and okay, here we go. So the first thing I want to point out is that the elevation is 236 feet, which is an amazingly perfect coincidence. If you're at 236 feet and you've got a camera on a tripod, your camera's essentially at 240 feet. So just keep that in mind. I honestly couldn't have planned this better. So what he's doing is shooting from this QAD parking lot, which is just south of Santa Barbara. And like I said, it's 236 feet. It's just right on shore, right along the shore, actually. And he's filming across the channel to the Anacapa Islands, which are 31 miles away, maybe 31.3. But anyway, I'll let it run. Actually, some of the videos that he made were some of the videos that really caused me to question whether or not the Earth was flat. He just did some really good work, I thought. So here I just want to point out that that's Anacapa Island, and the distance is, well, 31.1 miles. Okay. That is West Anacapa. This is going to be Center Anacapa. And what I'm going to do here is slow this down, because I need to stop the video quite a few times. And otherwise it's just too fast. I can't catch it. So As I said, he's in the center island. Now there's 3 islands. Okay, you'll see what I mean about how fast this is. At normal speed, I just couldn't keep up with it. Okay, so that's the end of the center island, and then there's a little gap, and that's the beginning of East Anacapa Island. So this section right here is 200 feet in elevation, and this is 160 feet. I will show you that here. So this is the 200 feet. The camera's moving across this way. That's 200 feet. And the reason you know that is, hold on a second. Get my pointer. Okay. So the reason you know this is 200 feet is because the contour line for 200 feet is the dark line. And contour lines are every 40 feet. So there's going to be, you can see, well, this is an easy place to see it right here. 40, 80, 120, 160, 200. So there's going to be 1, 2, 3, 4 contour lines, and the fifth one is 200 feet. So this is 200 feet in elevation, then it drops down to 160, and then it comes back up to 200 right here. So let's go back to the video. There. So see how this is the 160 foot area, and then it quickly goes up to 240 feet. And I'll show you that just so it's clear. So it quickly goes up, and there's the 200 foot contour line, and then this little contour line right in here, along with this little dot and this area here, and actually this little area right over here, those are all the next contour line, which is 40 feet. So this is 240, that's 240, that's 240, and this one on the opposite side is 240 feet. And if you look at the video, so right there is 240. Now the other thing I want to point out about that is it could be 250, 260, 270. As long as it's at least 240 feet and not 280 feet, then that's what that contour line is going to represent. But I'm just going to assume that it's about 240 or 245 feet, just based on how the island looks. Now we continue on. It goes down a little. Notice that here it's descending a little bit, so we're below 200. That's that area that's below 240 feet, and then it goes up again. And so this is 240 feet again. And the reason that I say that it's pretty close to 240 is it doesn't really go up a lot. It's maybe 20 to 30 feet. So it could be 250 feet, but not much more. And then he just pans across the island, and all of this is obviously less than 240 feet. So that's this. So he hit the 200 feet, down to 160, then all the way up to 240, and then it went down a little bit, back up to 240. And then it just kind of, the camera pans across, and all of this is at least 200 feet high, but not 240. Until it gets to here, which is Anacapa Island Light, which is the lighthouse. And you'll see that there's a little tall section, like a little mountain or a mound or a hill, right behind the lighthouse, which is also 240 feet. And you'll see that right here. It's pretty obvious. So all this is less than 240. And then you get to the lighthouse, and there you have it. It's obviously higher than the rest of the island, and that's exactly where the lighthouse is. That's exactly what the topographic map shows. Now he's going to zoom out a little and pan back. So that is actually an oil platform that's much closer. I think it's maybe 8 miles offshore. That's why it looks so clear. So there he pans back, and you can see that that section of the island is taller. And then kind of moves along all below 240 feet, below 240 feet, and then you have this high section here, that's that 240, and then it dips down, and then you have that other 240 foot, and then down to 160 and back up to 200. Okay, so what I'm going to do here is I really want to just go back to this, right? Went back a little too far, but I'm just going to stay with it. Okay, here we go. Right there. So you've got this platform here, and it's directly between this 240, maybe 250 foot mountain, but we know it's at least 240 feet, and we know it's not 280. And we also know that there's not a lot of elevation gain on those higher areas, so I'm assuming it's pretty close to 240, maybe no more than 250. And we know that the camera is at 240 feet. So what I'm going to show you here that I found interesting is the height of this platform. First of all, what I want to do is show you this. This platform is actually called Grace. And if you look, it's a different angle, but notice this crane and that pole, and then the second crane. If you see, here's the crane and the pole. Obviously, the angle is from off to this side looking back at Grace, and then there's the second crane. So what I want to show you also is it is actually platform Grace. Here's a map that I found, and let's zoom in just a little bit. So this is Summerland. I'll show you some better imagery here. Right about there is where QAD is. And Catalina, or East Catalina Island, is right there. And no, it's this one. Platform Grace, Operator Venico. So that is the actual platform we're looking at, and it is in a straight line QAD. What I did was I made a copy of that map, and I added in the line of sight. This is going to take forever. So there's that nearer platform that I was talking about, much closer to the shore. And here's Summerland. So what we're going to do is zoom in on that. There you go. QAD. So I've got two lines. I put in a line of sight, so that way I could go straight over the top of Platform Grace all the way to Anacapa Island East, and I'll show you where it crosses both of those points. And then the second dash line is a measurement line. So zoom out again. This is really the only way I can do this. It's a little cumbersome, I know. So there you have it. Offshore Platform Grace, and 18.5 miles. Keep that in mind. That is very important. And here we go. This is East Anacapa Island, exactly as we saw on the topographic map. You can see it looks the same. It is the same island, has the same, I mean, we saw the lighthouse and the shape of it's the same. And this high area right here, where is it? There, all through here, if you notice, It's called Inspiration Point. So it's kind of the high spot on the island. The reason I'm showing you this is just to show you that we are actually looking at East Anacapa Island, and we are actually looking at Platform Grace. So the question arises, what is the height of Platform Grace? As I said, I originally thought that the platforms were a couple hundred feet tall, or even taller than that, maybe 225 feet, and I was wrong about that. Bo and I did a lot of research, particularly Bo did. He contacted Veneco and sent me a lot of emails. He was able to find out that the helipad on top of Grace is 120 feet tall. But I cannot find that information anywhere online. It's just, you can't find it. And I think the reason is that the helipad was added later on. So helipads are listed in a database with the coordinates and the elevation. Pretty much any sort of airport is going to be. So what I've done here is I'm going to use another platform which does list the elevation of the platform. So this is Platform Habitat, and it's the heliport information. So they give the there we go, the coordinates. And the estimated elevation is 90 feet. So keep that in mind. And this is something that we worked on quite a bit. I'm very confident of that number, but I also have a graphic here that will really lend credence to that. So here's my side-by-side image of the two platforms, Habitat and Grace. So again, there's that pull for the crane. This arm that sticks out to the side, you can't see it from the angle we're at because it's kind of aiming back towards the island. But, I mean, I've pretty well established the fact that it is Grace. So, the above two images are scaled using the handrails as scale references. I am assuming that the handrails are 48 inches in height. And the reason I'm doing this is because I measure the handrails all around my house, and they're actually 42 and 44 inches. I'm assuming that handrails out at sea are going to be at least that and maybe a little bit higher because of safety reasons. Waves and wind, it's a dangerous environment. So you're going to want at least 42, probably 48. So I just went with 48. It doesn't really matter because you're just talking about the comparison between the two platforms to try to estimate how tall Grace is. But I went ahead and used 48 inches and it worked out pretty well. I'll continue reading. According to available resources, the helipad on Platform Grace is 120 feet in elevation, and the heliport on Platform Habitat is 90 feet in elevation. It does seem apparent that the heliport on Grace is located at a higher elevation. Upon visual inspection, it does seem apparent that Platform Grace has more floors and is taller than Platform Habitat. Based on the collected data and visual appearance, the assumption of a 90-foot elevation helipad on Platform Habitat and a 120-foot elevation helipad on Platform Grace was made for the purposes of conducting this visual observation. So I want to just zoom in here real quick to show you what I did. So right there is the rail. And that little green bar is the height of the rail. Now I did the same thing on Grace, the height of the rail. I tried to scale these as close as I could, just based on the crane size and the tubing size, the handrail size. I'm trying to get them as close as I could to being the same scale, the images. And you can see that there are 23 of these 4-foot sections on Habitat, and that comes out to 92 feet. It's actually maybe a little bit higher, sticking up higher, and Habitat is supposed to be 90 feet, and that's the helipad right there. So you do the same thing with Grace, with the same little green bar, and 30 times 4 is obviously 120. So I can state with a great deal of confidence that Platform Grace has a helipad that is 120 feet tall. I don't think there's no doubt. It could be a couple of feet one way or the other. but it's very, very close to the actual height. Okay, so now what I'm going to do is, let's go back to the shot from Beau's video. Now this is the thing that's interesting. This island is 240 feet tall, and the camera where we're filming from is 240 feet tall, and this platform is 120 feet tall. So if it's 120 feet tall, why is it the same height, essentially, very, very close to the same height as Anacapa Island? This is, I mean, I cannot, is it that Anacapa Island is sinking down? What is that? So it's 240, and that's, so it's sinking down 120 feet to create the illusion that platform Grace is that big. I mean, I guess that's possible. So the other thing is that we're shooting from 240 feet. We should be looking down on platform Grace. And if you notice here, you can't see the top of the helipad. You're kind of looking almost up at it or straight across. But that's the least important part. The thing that really gets me is that it is appearing to be 240 feet tall. So now what I'm going to do is show you another graphic that I made. And it's right here. So this is what we should see, I would assume, if the Earth is flat. So I'm just going to read this. What we should see on a flat Earth. This illustration is what we would expect to see on a flat Earth. What was actually observed was very different. Grace did not appear to be 120 feet below the line of sight, as would be expected. It appeared level with the line of sight. And it's a pretty basic diagram. Camera's at 240. Highest point of Anacapa is 240. The heliport on Grace is 120 feet. I would assume this is what you would see. I mean, I can't imagine why you wouldn't see exactly that if the surface of the water was flat. And I'll go ahead and read this. The camera is located at an elevation of 240 feet, which is the same elevation as the highest point on Anacapa Island. The heliport on Platform Grace is 120 feet above the surface of the ocean. On a flat Earth, Platform Grace should appear 120 feet below the 240-foot high line of sight, formed between the camera and the highest point of Anacapa Island. In the observation, however, we see that the top of Platform Grace is essentially level with the line of sight. In this observation, there is a 120-foot deviation from what we should expect to see on the flat Earth. So it's off by 120 feet. Essentially, that's the deviation we're seeing. This is what I find very compelling. Okay, now I'm going to go back to, we're going to go to something new here, which is the correct way to calculate the height of a section of an arc, of an overall radius. And the way that you do this is you're going to enter in the radius of the circle. So that would be the Earth. And I'm doing, if you notice, it says in feet. So what we're going to enter in is the radius of the arc and then the length of the arc. The radius of the Earth in feet is 20.9 million. I've entered in 20.9 million here. And then the length of the arc, as we discussed before, is 31 feet. 31 feet, or 31 miles, I'm sorry. 31 miles in feet is 163,680 feet. So I've got 163,680 entered in there. And let's see what we get. So the height of the arc, right here, from there to there, is 160 feet. And you can get this in every single circular arc calculator will give you the same answer repeatedly. I've checked a bunch of them. Okay, so take that 160 feet, and now let's see what platform Grace should look like using that number and constructing an arc between the mainland and Anacapa Island. And that's what I've done. So we will close that and then go here. And this is what we should see on a globe Earth. This illustration is what we should expect to see on the globe Earth. What was actually observed was only slightly different. Grace did not appear 10 feet above the line of sight, as would be expected. It appeared level with the line of sight. So again, the camera is located at 240 feet. Highest point of Anacapa Island is 240 feet. The heliport on Grace is 120 feet. And the height of the arc, as we saw here, is 160 feet. So 160 plus 120 is 280. But there's something interesting about that. So at 280, of course I said here that Grace did not appear 10 feet above, so I see a 10-foot discrepancy. I'm going to explain why. Because actually, according to the globe math, the heliport on Grace should appear, if you're using a straight line from the camera position to Anacapa Island, and you're assuming it's 240 feet, then Grace should be approximately 10 feet above that line. And this is why. So the camera is located at an elevation of 240 feet, which is the same elevation as the highest point on Anacapa Island. The heliport on platform Grace is 120 feet in elevation. On a globe Earth, we should expect a 160-foot arc over 31 miles, like we saw on the calculator. If we add the height of Grace to the height of the arc, we get an expected visual height of Grace of 280 feet. This would be the case if Grace was at the apex of the arc, but it is not. The apex of the arc is at 15.5 miles. And what that means is it's the highest point of the arc, right there. So if you have an arc that's 31 miles long, then 15.5 miles is going to be the highest point. Grace, though, is actually 18.5 miles from the camera. So you can see I put it right in between 18 and 19. On the globe, Grace is over the apex of the arc and down lower on the back side of the arc by 3 miles. So this is important for the calculation. As half of the length of the arc is 15.5 miles, so in other words, from here to there is 15.5 miles, then for each mile the arc raises in height approximately 10 feet. So 15.5 miles times 10 feet for each section equals 155 feet. And we know from the circular arc calculator that the rise is 160 feet. So it's 10 feet, 2 inches maybe, 10 foot and an inch. But hopefully that makes sense. So it goes up 10 feet here, and then 10 more feet, 10 more, 10 more, 10 more, until eventually you're up at 160 feet. Well, conversely, on the backside of the slope, it goes down 10 feet for every mile. So you go from 160 to 150 to 140 to 130 feet. So we need to subtract 30 feet, which is 3 times 10, which I just explained, from the expected visual height of platform Grace. Therefore, on the globe, Earth, Grace should visually appear to be 250 feet high. 280, which is the 260 plus the 120, minus the 30, because it's over the apex and down the backside. Or 10 feet above the line of sight formed between the camera and the highest point of Anacapa Island. In this observation, Grace appears level with the line of sight, and so the deviation from the expectation on the globe is 10 feet. And the other thing is to keep in mind is that contour lines, they represent a range. So when the contour line on Anacapa Island is, the highest one is 240 feet, and you don't see another one, well, the next one would be at 280. So it's very possible that Anacapa Island could be 250 feet high. It doesn't seem out of question at all. And if it were 250 feet high, then it would match the observation that you're seeing exactly what you're seeing in that shot. So does this shot, I mean, this is the question I'm asking myself, does this shot look more like this? Is it up high, right in the way of the highest part of Anacapa Island? Or does it look like this? Is it way, way down below that line of sight? And, I mean, the answer is obvious. It's up really high. Why? Somebody tell me why. Someone who is convinced that the Earth is flat, I would like an explanation of that. And then someone who's convinced that the Earth is globe, I would like you to counter that explanation. And I'm asking people to do this with math for refraction and compression, whatever you want to do. And let me know, because to me, this looks like the camera and the island are dropping off, and Platform Grace is very near the apex of the bulge of water in between the camera and Anacapa Island. But maybe there's an alternate explanation. I'm just letting the evidence take me where it is naturally taking me, which is to this conclusion. So, and if this doesn't make any sense and I'm crazy here, then by all means let me know. But that is it. That is my video. I'm sorry I am so long-winded. It's just the way that I do things, and I know that I repeated a lot of stuff, but I like to be thorough. I haven't missed anything. There's our maps. Platform Grace. Carpinteria's right near Summerland. It's all there. There it is, Grace. The circular arc calculator, and this is mathematical, scientific. My measurements are accurate. 18.5 miles, 31 miles to Anacapa Island. And my diagrams, I try to do them as accurately as possible. The side-by-side comparison, I think, really shows that we're dealing with a platform that is very near 120 feet. It's definitely not 240 feet tall. I mean, this is small compared to 240 feet. And I'm just looking over my list here, and actually, I did forget something. So, not hugely important, but just a verification for you. I want you to know that when I say you're looking at something, that you're actually looking at it. This is a search for oil platform Grace. I put Grace first so that I would see it up here in the tabs and remember to click on it, which I didn't. But anyway, it's just there so you know that there you can see right here oil platform Grace. And then actually offshore platform habitat, which this is something I hadn't verified at all for you without showing you that image. So this is habitat. That's the heliport at 90 feet high. And let's go back to, well, actually, let's see what this looks like. Get a better shot of it. So, slightly bigger, but that is clearly the same platform that was in the side-by-side comparison. And as I said, that's 90 feet tall. To the top of the heliport. And then here's Grace. Look at that. And clearly, it's the same platform. There's the big pole, the two cranes, this swing arm that kind of moves around, and so we're not able to see it from the angle we're looking at, but it's obvious that this is a taller platform, so it's obviously taller than Habitat. As I said, we did verify the 120 feet. I've done a lot of work on it. I feel very confident. I mean, I know it's not 240 feet. That's obvious. And then one thing here is this angle. which we're looking up at this, and you can kind of see under everything. Brings me back to, let's just revisit this real quick. Here. So, obviously, the main crux of the argument I'm putting forward is that Grace is towering way above where it should be. I'm assuming it should be about half the height of the island, right about here, at 120 feet, because the island's 240 feet, and it's towering up at 240 feet. But this whole issue of the angle is actually really interesting if you consider that Bo is sitting, he's at 240 feet elevation, looking down on this platform, and he's got an amazing camera that he's zooming in with from 18.5 miles away. But his angle is from above it, looking down. And, I mean, I've been alive long enough and been looking at objects that are taller than me to get a sense that I'm looking not only straight across at this, I actually feel like I'm looking up at it from a lower vantage point. And the reason is I don't see, like if I were looking down from 240 feet, I feel like you would see an oblique angle of the helipad or some of the upper platforms. You would kind of see the upper surfaces, obviously, if you're looking down. And I really feel like I'm looking at the underside of these floors. Like, so here you see these connectors for the pillars that hold the platform up, and you can look at these pillars on the backside. It's almost like you're seeing up under all the way to the backside. Here, it looks like you're looking from down below and up, so that we're down here, we're not up high. And on a flat Earth, I don't understand how that is possible, because we should obviously be looking down at it. But if this is a globe that we're on, let's say, and the math that I did from the circular arc calculator, which told us that we were at 160 feet, so that this platform is sitting on an arc that's 160 feet tall, but it's over the backside, then it would be tilting away from the camera and towards the island, and would actually, I'm assuming, create something very similar to what you're seeing. Because we're not looking down on this. I'm not seeing the upper surfaces, I'm seeing the undersides of these levels. And actually, is that closer? There it is. Somewhere in there. There's this platform that is maybe 6 or 7 miles offshore that he catches right here. So, there, you're definitely, that's exactly what I'm talking about. You're seeing an oblique angle of the upper surfaces. I mean, I feel like that I'm looking down on this, that wherever I'm at, I'm above this platform looking down. Not a lot, and I mean, it wouldn't feel like a lot because the angle's going to be very subtle, even at 7 or 8 miles, whatever this is. But we're definitely above it. But then why wouldn't it be the same for, there we go, for Platform Grace? We're looking at it from below it. So that, I think that is something very interesting to consider. I would like, I mean, is the light bending? And somehow our view is coming down from below, even though we're above? So that's another interesting point to, maybe, possibly, to this presentation that I'm making here. But the main crux of the argument that I'm putting forward is the height of the platform, and the fact that it is much higher than it should be. So, that is it. That's all for my presentation. I look forward to any feedback. I think this is an interesting point that I myself, I cannot reconcile these, the tilt of this platform back and how we're looking up at it, and the fact that it appears to be about 240 feet high. I don't know how to reconcile that with flat Earth, but if someone who firmly believes the Earth is flat, if you could reconcile that for me, I would appreciate it, because I find this very compelling, and it makes me question the whole flat Earth theory, quite honestly. But I am open to an alternate explanation that does actually incorporate the flat Earth theory with these observations. So that's it. Thank you for your time, and again, sorry I'm so long-winded, but like I said, I like to be maybe overly thorough. But thank you for your time, and I look forward to hearing from you.